Hey guys, so welcome to this new video. So in last video we discussed upon the various approaches and we were waiting for the pandas profiling report. So the report has been completed. So now to view it correctly, so let us save it into an HTML format. So the way is to do it like that. So, okay. So it looks like so the panel has been restarted. So anyway, so we'll look it from here. So now pandas profiling, this is a very extensive overview of the data. So as you can see here 17 variables and this many number of observations and 6.5% missing values, and it is taking around 600 MB of data, and there are 15 numerical and 2 categorical values. Okay, so let us first look at the alerts. It will give us a high correlation with values. So as you can see, row ID is the cardinal, has high cardinality. Distinct values, obviously date ID is also for distinct, and reference price is correlated with fair price and four other things. Okay, fair price is correlated with the reference price, near price with the reference price, bid price is correlated with the reference price, ask price is correlated with reference price, wrap is also correlated with the reference price. So maybe using this correlation message we can make some extra features, or we can do some feature engineering with that. Time ID is also correlated with date ID obviously, and fair price, hard price and near price are the most missing values. And last video we discussed about removing the values before 300 seconds, but it is not plausible. We will look into it further, and we will look into it why it is not plausible. So now next we are going to look into seconds in bucket has also some zeros, and imbalance has also some zeros. So yeah, so this is the stock ID. As you can see, it is almost distinct. Date ID is also distinct. Seconds in buckets, there are some zeros in that. Okay. Imbalance size, you can see. Okay, there are a lot of zeros. Imbalance buy sell flag, as you can see, there is -1, 1, and 0, and it is quite a good distribution. Maybe we can distribute this using p.dummies into 3 different variables. That would be helpful. And reference price seems to follow a very high normal distribution, and match size also 0 is very highly predominant. Far price, there is missing and highly correlated with 5 fields. Near price also we can see there is high correlation, and bid price there is some Gaussian structure you can see. Ask price also Gaussian structure is there. WAP also some Gaussian structure is there. Time ID is obviously distinct. Row ID, this is the interactions. Okay. Correlation, as you can see, far price, near price, bid price have some correlations. We will devise some categorical features using feature engineering. So missing values, okay, these two have some very much missing values. Yeah, so this is a sample of the dataset. So yeah, so this is an overview of the data that we have. So what I wanted to discuss is seconds in bucket. So as you can see, we have from 0 to maximum 540. So if we decide to remove all the data before 300 seconds, that would be a huge loss of data. So maybe we cannot do that. We have to handle the missing values differently, or maybe ignore it for a while. And Yeah, so the earlier strategy that we had of moving the first 300 seconds, we will ignore this for now, and we will focus more on the feature engineering and then the model selection. And another thing that I have noticed is that is the memory. So there will be a huge memory problem. So what we can do is we can optimize the dataset. So optimize the dataset means we will convert all the fields data types into object. So this will basically improve the memory utilization. We will use garbage collector as it will use many others. This will improve the memory structure, and also while inferencing we have to use the given API. For the given API also we have to do some memory optimization. So this has been done by some Kagglers, and we will look into them. So the main thing that we have to do now is feature engineering. So as I was talking about feature engineering and reducing memory, so this work has been done by Renato, and he has suggested translating the data frame data types that will minimize the memory usage. So we can do that, and after that, feature engineering is doing some feature engineering. So let us delve into it. So as we discussed or saw in the data in the EDA, we saw that there was imbalance by flag. There was -1, 0, and 1. So we can distribute it into various three columns. Similarly, imbalance cell flag also we can distribute, and we can as we saw there was a high correlation in the bit size and ask size, and bit size and ask all the size. Price will lie within the bit size and ask size, so we can maybe combine that. It will give us a total ask sizes. And now we can for the stock ID we will calculate the medium volume, and we will find out the high volume stocks by checking the stocks that we have high medium volume, that we have volume greater than the median, and we'll put that in the high volume stocks, and we'll find an imbalance ratio that will be the ratio of imbalance size and max size. So next we will find out some two columns, that is found out two columns, bit size plus bit size minus arc size plus. So this I do not know what about this, and this is some another ratio that he has found out. And next is finding out the x size, that is multiplying the ask size and ask price, so it will be the total cost. And so yeah, these are the various EDA feature engineering that he has done. So some of the ratios I am not aware of them, maybe some domain expert can delve more into it. And after using that, memory usage has been decreased by 16.959%, so that looks to be we can use probably that. And yeah, so let us try this memory optimization technique, and feature engineering also I think we can delve more into it. So maybe what we will do is let us, where is that? Yeah, so let us copy sample. Let's copy the first 4 or 5 samples, put it into ChatGPT, and then also I will give the alerts. And then also you will need to provide him the meaning of the words. So let us first check. So until he's giving out, so let us also provide him the this one. So here is the description. So we will copy that and provide it into ChatGPT. So now let's wait for the. Okay. So it is telling us time related features. We have seconds in bucket. It is telling us to extract hour of the day, minute of the hour. That maybe we can do, but I do not think that might be an important feature. Okay, we'll think about it. Second is talking about he's talking about the ratio of imbalance size to match size as we are talking. Also is telling us to calculate the rolling statistics of imbalance size for a specific time interval, captured and model capture. Price related features, you can calculate the price spread between these. Okay. Percentage difference between this and that. Rational features, as we have talked, create three variables. Statistical aggregation. Statistical aggregation for this. Okay. Temporal features. Rate of change of key features over time. Read or ask features. Features of the time difference. Current read price of the previous ask price. That looks a little bit non-useful. Hero indicators. Nah, we don't need to look into the missing values. Interaction features. Categorical encoding, that this thing you can do. Lag features. Processor features. So some of the ideas looks good. Maybe you can combine, you can do some imbalance features, you can do some rolling statistics around the things, you can do some statistical aggregations and look around the time analysis. Also maybe you can look into the time related features, you can look around the movement of the stock in the different hour of the time. Maybe the last hour may be more useful than the other time. This may be an important feature, and that summarizes it. And we will look into the, as we discussed, we will look into the ratios, and the ratios might be important or useful, and also we will look into the numerical aggregations, statistical aggregations. So now this is our task. We will look into the numerical statistical aggregations, and as discussed here, we will use this as our basic feature engineering. Along with that, we will do some statistical aggregation and also look into the time analysis of data. So this is for it. So we have devised the scheme. We have looked into the data. We have explored the data basically extensively. We have understood what EDA can be done, what feature engineering can be done, and now based on this basic notebook, we will do this feature engineering and the statistical analysis. So that's it for now. Looking to see into the next video. Thank you.